Alright guys, today what we're going to be going over is how to reduce radicals. We're going to need this later in the chapter when we get to special right triangles. Also, we're going to need them for any triangle that is not like a perfect triangle, like in when we're doing Pythagorean theorem or something like that. If the numbers don't work out perfectly, then you have to reduce radicals. So, we're going to first start, what is a radical? Well, in mathematics, a radical is anything that has a root sign. Okay? So usually we deal with square roots, which means roots of 2. Now the root can be bigger. It can be a cubed root, which will have a 3. It would have a 3 right here. It would look something like this. Or a fourth root, which would look something like this. Or a fifth root, so on and so forth. The numbers in the same place. But we're going to be dealing with these right here. So what is a radical? It is a square root. You can write that down. Just make a picture of that, whatever you need. That is what a radical is. Now, we're going to get into how to break down, actually figure out what a square root is. A square root by definition is just asking you what number times itself equals the number on the inside of this radical. Well, right away when looking at stuff, you're not always able to check. So this is how I teach you guys to actually break it down. So first, let's think of a number that'll go into 36. Alright, let's go with 6. Alright, 6 times 6 equals 36. Well, let's keep breaking that down. Now, technically we could stop here, but I'm going to keep breaking it down just to get you guys used to the idea of what we're going to be doing later on. I'm going to break this 6 down into 2 and 3. 2 and 3. Alright, now, we can't break 2 or 3 down anymore, so we're actually, we're stopping, so where we're at. Now, because this is a square root, it means we take things out in groups of 2. We take numbers out in groups of 2. So right now we have 1, 2 2's. So that's one group of 2's. That's what we're going to do. We're going to take this, we're going to bring it outside. So these 2 became 1, 2. Okay. Then we're going to bring our 3's out. These came out as just a 3. Now, whenever we bring in more than one number outside of a root, we actually have to multiply them together. So if we take 2 times 3, we should get 6. So the square root of 36 should give you 6. 196. All right, let's break this down. I'm going to guess 4. All right, so you don't always know a number that's going to go into, so I'm just going to say 4 for right now. So what it looks like is I'm going to put 24 and 4, because if you take 196 and divide it by 4, you should get 24. Well, 24 breaks down into 4 and 6. Okay, this breaks down into 2 and 3. This breaks down into 2 and 2. This breaks down into 2 and 2. Actually, I'm sorry, that doesn't break down into 24. Scratch that out. I had a brain fart. Alright, sorry. This breaks down into 49 and 4. This breaks down to 7 and 7. This should break down into 2 and 2. So, remember, once again, we had to take things out in pairs. So here is a pair of 7's. Turns into 1 7. Here is a pair of 2's. Turns into 1 2. Whenever we bring things out of the root, we have to multiply them together, so we get 14. Now let's try 256. Alright, once again, I'm just gonna guess 4. If I take 256 divided by 4, I get 64 and 4. If I break this down, it should give me 8 and 8. This breaks down into 2 and 2. And we're just going to keep breaking it down until we get it into its base units. Alright, so now I've got a bunch of numbers here. I'm only looking at the numbers that don't have anything coming off of them. So here's 1, 2, 3, 4, 5, 6, 7. We have 8 2's. So we're going to bring these out in pairs. So here's one pair. Here's a second pair. Here's a third pair. And here's a fourth pair. So if we take 2 times 2 times 2 times 2, we should get 16. So technically this root, square root of 256, should be 16. Alright, so whoever's in the classroom, sub, whoever, can you pause the video right now? And you guys, I want you to try these on your own. I'll wait for the sub to pause it. Try these on your own. Okay, same idea. Technically, you can look at some of these and just be able to tell what the square root is, but I'm going to just go ahead with the thing so that way we get used to trying to break it down into its most basic parts. So 16 breaks down to 4 and 4. This breaks down again into 2 and 2, 2 and 2. So we have a count of 1, 2, 3, 4 2s. When we bring these out, they come in to pairs, so 2 and 2 makes 2 times another pair. So that means 2 times 2 is 4. So the square root of 16 should be 4. Let's write that down for a sec. Alright, square root of 441. Alright, so I'm just going to guess. Alright. Sometimes it's a guessing game. So you can do something small like start with 441 and divide it by 2. Well, that gives you a decimal, so that can't be it. So let's try 441 divided by 3. Well, if we take 441 and we divide it by 3, we should get 147. Alright, now 141 kind of looks like a hard one too, so let's try 2 first. Well, 2 doesn't work, so let's try 3. Well, if we divide this thing by 3, we should get 49. 49 is kind of easy because it breaks down to 7 and 7. Alright, so we've got this number that's the end, this number, and this number. So these got to come out in pairs. So we have a pair of 3s that are going to come out, so we're going to have 3. We have a pair of 7s that are going to come out, it's going to be 7. And we're going to multiply them together, so 3 times 7 equals 21. The square root of 441 is 21. Give me a second to write that down. Alright, let's try this next one. 324. So once again, I'm just going to start. We don't really know. I'm just going to use 2. Alright. So if I divide this by 2, I should get 162. Alright, well 162, let's say. It's got a 2 in it, so let's try 2 again. This breaks down into 81. Alright, well let's break down this 81. It comes 9 and 9. Both these 9s break down. So once again, we got to bring these out in pairs. It's 1, 2, 3, 4, 5, 6 numbers we're working with. Here's a pair of 2s, so it comes out as one single 2. Here's a pair of 3s, so it comes out a pair of 3s as 1 3. Here's another pair of 3s. So if we take 2 times 3 is 6, times 3 which should give you 18. Let you write that down. Alright, move on. Alright, turn your page. Now, those last ones are called perfect roots. The reason why they're called perfect roots is they come out perfectly. They don't have anything left under the radical. So now what we're going to do is we're going to reduce we're going to reduce the numbers under the radical. So using the same idea, remember everything has to come out in pairs of 2. And that we always have to break everything down into its base elements. So 48. Well, let's use 2 and 24 again. Alright, let's break that down. 24. 4 and 6. Well, 6 breaks down into 2 and 3. 4 breaks down into 2 and 2. So we have 1, 2, 3, 4, 5 items in this case that we've broken it down into. So remember, things have to come out in pairs. So we got one pair of 2s. So these 2 right here comes out as a single 2. Then you have these 2 comes out as a single 2. But we have this 3 here. This 3 doesn't have a partner. Alright, it's like going to prom. You don't want to go alone. So the 3 is going to go back to its house, which is under the radical. So this is what we're going to do. We're going to take the 2 numbers that we were able to bring out, 2 and 2. We're going to multiply them together. We're going to get 4. And then we're going to put 3. 3 is going to go back home, which is under the radical. Alright, because we can't take the square root of 3, the answer is done as is. So we were able to take out 1 pair of 2s, 2 pair of 2s, but not this 3 because it didn't have a pair to go with. So it ends up being 2 times 2, which is 4. 3 stays under the root. Let's move on to the next one. Alright, let's try this one. Let's break this down. We're just going to say 2 and 81. This breaks down into 9 and 9. This breaks down into 3, 3, 3, and 3. So we've broken it down. We've got a 2, a 3, a 3, a 3, and another 3 right there. So let's start with the 3s. There's 1 pair of 3s, so 1 pair of 3s comes down. There's a second pair of 3s, so the second pair of 3s comes down. But this 2, once again, it's lonely. It can't do anything because it doesn't have a partner to come out of the house with. So we're going to leave it under the radical. We're going to take these 2 numbers, 3 times 3, which is 9. So we'll get 9 square root 2. 9 square root 2. Write that down for me. Alright. 180. Alright, so once again, let's just use the 2. It's been working for us so far. 180 can be divided by 2, so we're going to do 2. And when you put in your calculator, you should get 2 times 90 equals 180. If we do it again, 2 and 45. Well, now we can't do it again, so we have to break this down. 45 goes into 5 and 9. 9 breaks down into 3, and 3. Alright, so we have this 2, we have this 2, we have this 5, we have this 3, and we have this 3. So remember, they can only come out in pairs. So you've got this 2 is one pair. You have these 3s, second pair, but 5 doesn't have a pair to come out with. So it's just going to stay at home. Square root 5. 2 times 3 is 6. Square root 5. Let's copy that down. Alright, so you guys are going to try the U-try now. So if you sub in there, please pause it. You guys are going to do the next 3, and then come back. Give me a second to pause it. Okay. 72. Alright, so I'm going to use 8 and 9. 8 times 9 gives you 72. So if we break that down, 8 breaks down to 4 and 2. This breaks down into 2 and 2. 9 breaks down into 3 and 3. So all the things that don't have something coming off of them, we have 1, 2, 2 2s, 3 2s. Then we have 1 3, 2 3. Alright, so they have to come out in pairs. 2's come out in a pair. 3's come out in a pair. Well, right here we have an extra 2, so it's got to go home. So in fact we have 6 square root 2. Let's do the next one. Alright, let's say this divides by 2. Okay, so we get 686. Alright, I'm going to try to break this down by 4 now. Let's just see if that works. Nope, 4 does not work. So you can't do 4. So let's do 2 again. Gives me 343. I'm going to break this down by 7. 349. Break this down by 7 again, and 7. So we've got a 2, another 2, a 7, another 7, and a third 7. So they have to come out in pairs. So we've got a pair of 2s. 2 comes down. We've got a pair of 7s. 7 come down. This 7 doesn't have anyone to go out with, so it goes back home. 2 times 7 is 14. Square root 7. Give me a second to write that down. Almost done. Actually, we got a couple more sections. Alright, sometimes we have radicals on the bottom of fractions. Now, it's improper to leave them like that. So I'm going to teach you guys how to actually get rid of that. So, what we're going to actually be doing is we're going to be just multiplying the bottom and the top by the radical that we're trying to get rid of. So in this case, we're trying to get rid of the square root of 5 on the bottom. So this is what we're going to do. We're going to multiply by square root on the bottom. But what we do to the bottom, we also have to do to the top. So, when we do that, we get 3 times square root of 5, which becomes 3 square root 5. When you multiply these two numbers on the bottom, you just get 5. Because it's going to be one pair, meaning 5 times 5 is 25. When we break it down, it's going to turn into 5. So that would be the answer for that. This next one, we're trying to get rid of this thing on the bottom. Now, we're just going to be multiplying by just the radical, so this square root of 8. So we're going to multiply the bottom by a square root of 8. We're going to multiply the top by a square root of 8. So we multiply this bottom, we end up getting 3 times 8, because the square root of 8 goes away. On top, we'll get 2 square root of 5 times 8. Then this will turn into 2 square root of 40 all over 24. Now, we have to reduce a lot of stuff. So first, let's reduce this radical. So let's reduce the square root of 40 first. This breaks down into 5 and 8. This breaks down into 4 and 2. This breaks down into 2 and 2. So the only thing that's going to be coming out is this pair of 2's right here. This 2 and 5 stays under. So it becomes 2 square root 10. Now since we already had a 2 up here, we're going to have to multiply that other 2. So it's going to become 2 times 2, which is 4 square root of 10. So our new fraction is going to be 4 square root 10 all over 24. Now we actually have to also reduce these two numbers. So 4 and 24, you can divide both of those by 4. So if we divide both the top and the bottom by 4, you should get 1 square root 10 over 6. That would be our final answer. So to re-explain what we did, we had to get rid of the radical on the bottom. So we had to multiply the bottom and the top by the radical that was on the bottom. So when we did that, 5 times 8 became 40. And since we multiplied two radicals together, the radicals went away and just turned into a normal 8. So we would take 3 times 8 and gave us 24. Then we had to break down 40. That's what we did down here. When we broke it down, using the 2 in front, we broke it down into bringing out a 2, but we also had to multiply by the 2 in front of the radical to start with. So 2 times 2 equals 4, square root of 10. That's where we got here. Finally, we had to reduce the whole fraction, divide the top and bottom by 4. We get 1 square root 10 over 6. Do the next one. So this bottom, we want to get rid of that. So we have to square top and bottom by 12. So this becomes 2 square root of 6 times 12 all over 4 times 12. That gives us 2 square root 72 all over 48. We need to break down the, oh, my bad. So we multiplied both the bottom and top by square root of 12. So that means that's going to be 6 times 12, and since these are two the same, it cancels out. So it becomes 4 times 12, which is 48, to square root of 72. We need to break down the 72. So this breaks down into 36 and 2. This breaks down into 6 and 6. In this case, I'm just going to take these out as a pair of 6's. Okay, so it's going to be 6 times 2 This 2 is left over. 6 times 2 is 12. So it's going to give me 12 square root of 2. Alright, so this top changes into 12 square root of 2. The bottom didn't do anything. Divided by 48. Both the top and bottom can be reduced by 12. And what we end up with is square root of 2 over 4. I understand this is confusing, so right now if you guys still don't understand, keep watching. Otherwise, get started on your own. Okay, next one. Okay, so right now what do we gotta do? It's like what we've been doing before. Square root 7. We won't get out of the bottom, so we have to multiply the top and bottom by square root of 7. So this becomes 5 square root 7. The bottom just turns into 7. That's your answer. Next one. We get rid of the square root of 6, so we multiply the bottom and top by square root of 6. So this becomes 3 square root of 21 times 6 all over 4 times 6, which becomes 3 to the 126 all over 24. Now we have to reduce the 126. So we got 3 square root, 126. This breaks down into 21 and 6. This breaks down into 7 and 3. Breaks down into 3 and 2. So we have 7, a 3, a 3, and a 2. My only combination, our pair, is right there. So we take 3 times 3. 7, 2 go back under. 14. Which means we have 3 times 3 is 9. Square root of 14. All over 24. Top and bottom can both be reduced by 3. So if we do that, we should get 3 square root 14 all over 24. I'm just going to give you the answer to the last one because I feel like I've done a bunch of these already. But I'm just going to do this quickly. So we multiply by square root of 6 on both the top and bottom. So you get 2 square root of 8 times 6 all over 3 times 6, which will give you 2 to the 48 power all over 18. Next step would be to reduce 2 square root of 48. Breaks down into 16 and 3. It breaks down into 4 and 4. We can bring out the pair of 4s. So it becomes 8 square root 3 all over 18. The top. So remember, you don't have to write this part down if you don't want to. Bottom can be divided by 2. So it becomes 4 square root 3 over 9. Now I know this part's kind of hard, We'll be doing this again on Thursday for you guys. So don't fret. I'm going to try to re-explain it again on Thursday if you don't get it right now. Alright, last but not least, alright, I'm going to try the two of these. You try real fast because students are about to walk out. Alright, so we know A, we know B, we know C. So A squared plus 5 squared equals 14 squared. So that means that A squared plus 25 equals 196. Subtract 25 from both sides. You should get A squared equals 171. I can tell you right now that if we square root both sides, A, you can't break down 171, so it just stays as 171. Give you about 15 seconds to write that down. Alright, last one. So A, B, C, 12 squared plus 15 squared equals C squared. So, if we take 144 plus 225 equals C squared. When you add these two together, you get 269 equals C squared. We had to square roots both sides. Once we square roots both sides, we know we got to break this down. So 269 breaks down. Let's divide both sides by 3. That doesn't work. Let's try 9. That's not going to work. Let's divide by 7. Nope. Divide by, I don't know. Let's try 11. Nope. Let's try 13. Nope. Try 17. Nope. Alright, looks like 269 is prime, so that's your answer. So if you guys have any questions, feel free to come next door. I'll have an answer key for you guys next time if you need it for the homework. But please try this out and let me know. Alright, thanks.